Okay, before the break, we started learning about system of equations, which is more than one equation. We always work with two equations. Now, the first way we learned how to solve them was just to graph them and see where they crossed, and where they crossed was their solution. The second way we learned how to solve systems of equations was elimination, where we eliminated one of the variables. Today we're going to continue elimination, but before we can actually do it, we have to set up the two equations because everything is going to be given to us as a word problem. Okay, so we're going to use a procedure, and that procedure is known as rules. Now, as you can see, you have a dot after each letter, so it's an acronym. Each letter of the word rules represents a separate word. Okay, now at the top of your page, on page 7, you'll see 3 sentences. The first one starts with the word remember. You're going to fill in some blanks. Remember, a system of equations in Algebra 1 is, and then you're going to fill this in, two equations used to find a solution, x and y. So go ahead and fill that in. Your quiz grade? It's been on Infinite Campus since before the break. Oh, remind me at the very end of class. Okay, oops, hold on. Sorry. It skipped a few slides. Let me go back. Okay, the second statement up there says using rules, we will, and then it's a long blank. You'll fill in the blank, write two separate equations before we solve using substitution and elimination. Now, you can write that word substitution, but really there's no need because we've never learned the process of substitution. We're going to solve all of these with elimination, okay, because we haven't learned substitution and we're not going to. I just wouldn't write it. Okay, and then the third statement says, these problems have two variables, one for each unknown. Okay, does everybody have all 3 of those statements filled in? Okay, moving on. Okay, now below in that first box, you'll see a large capital R. R represents, remember this is rules, R-U-L-E-S. The R represents read the problem. Okay, it's obviously the most basic step. You have to do it. You really need to read it more than once. Even I have to read problems more than once most times. Okay, because the first time you kind of read through it and you didn't really get much of what it said. You have to look back at it and kind of zone in on what's important. Okay, and it's like a recipe, the content matters. So, a group of people bought movie tickets at the Circle Center movie theater. They bought a total of 7 tickets, some adult and some kid tickets. They spent a total of $72. If adult tickets cost $12 and kid tickets cost $9, how many of each ticket were purchased, or how much of each ticket was purchased? Okay, so we've read the problem. Now we're going to underline the question. We want to know, what is the problem actually asking us for? So in this particular word problem, what are they actually asking us? Right. How much of each were purchased? How many of each type of ticket were purchased? Okay, now we're going to define our variables, x and y. What are the unknowns here? Right, Peyton, you're on the right track. Right. How many adult tickets, how many kid tickets? So, X could represent adult tickets, Y could represent kid tickets. Do you see in your packet where to write that? You don't have to write all that. Okay, so we know that they want us to find out how many of each type of ticket were purchased, and our 2 unknowns are how many adult tickets, how many kid tickets. Okay, now we're going to line up a plan with the facts. Okay, this basically is where you're going to set up your 2 equations. So first we're going to cross out unneeded information. you read back through this, what really isn't needed for us to solve this problem? Right. I mean, technically, if you just started, they bought a total of 7 tickets, wouldn't you still be able to answer the question? And it definitely is not important what movie theater it was, right? What's important is that they bought a total of 7, some adult and some kid. They spent a total of $72. Yeah, but to be able to find out how many total ticket, or to find out of those 7, how many adult and how many kids there were, you have to use this other information they gave you. Because, I mean, think about it. If I told you there were 7 tickets bought, I mean, would you really know how many were adult and how many kids without any other information? It could be like 6 and 1, 1 and 6, 3 and 4, 4 and 3, 5 and 2. Well, because we're going to use this other information about the cost of an adult ticket. An adult is 12, a kid ticket is 9, and the total was 72. We're going to be able to use that to figure it out as well. Because remember, these are systems of equations. So we need 2 equations, not just one. Okay, just keep watching. Okay, so now we're ready to set up the equation. Okay, there they are. Like, don't worry about all. Okay, so here we go. We're going to set up the equations. We use X, remember, for adult tickets, and we're using Y for kids tickets. Now, currently, do we know how many adult tickets were sold? No, so we can't put anything beside the X because we have no idea right now how many adult tickets were sold. Do we currently know how many kid tickets were sold? No, but don't we know together that those tickets add up to 7 total tickets? So there's your first equation. It says the adult tickets plus the kid tickets totals up to 7 total tickets. Everybody with me on that equation? Okay, but remember, we're doing systems of equations, which means we need more than one. So we're going to have another equation with X and Y, and what is it going to total up to? $72. Okay, but guys, that's a dollar amount. So doesn't that mean that we need to put the dollar amount on each ticket over here? How much money were adult tickets? $12. And how much money was a kid ticket? $9. Okay, the reason you have to put 12 and 9 is because this total was about the amount total. So we need to put how much each ticket is worth. Okay, so now we're ready to solve it by elimination. However, if you think back to before the break, does anybody remember how to do elimination? Right? We want to add it, and we want something to cross out. But if we started adding right now, isn't that a 1x and that's a 1y? So 1x plus 12x is, so that doesn't cross out, does it? And 1y plus 9y is 10y. So currently as it is, did anything cross out? No. What could you do to make something cross out? Right. Like, would it have been nice if this had been like a negative 12 sitting right there and then those would have crossed out when you added them? Well, can't you just multiply that entire equation by negative 12? So if I multiply this entire equation by negative 12, that becomes a negative 12x. Negative 12 times y is a negative 12y. And negative 12 times 7 equals a negative 84. So do you see how I just took the top equation and multiplied every part of it by negative 12, and it became negative 12x minus 12y equals negative 84? So now can I technically just ignore this because it's been changed to this? Okay, so now I'm ready to do elimination because now I have a variable that will eliminate. And which variable is it? Right, 12x plus negative 12x is 0x, so it eliminates. What about 9y plus negative 12y? Negative 3y though. And then what about 72 plus a negative 84? Negative 12. Yeah, 72 minus 84 is... Okay, so now to solve for y, what do we do on both sides? Divide by that negative 3 to get it away from the y. And so y equals negative 12 over negative 3, which is 4. 4 what? No. Y represented what? Kid. Y was kid tickets, remember? So this is for kid tickets. So if we have 4 kid tickets, that automatically means we have how many adult tickets? 3. And how do you know that? Because there were 7 total tickets. Okay, if there's 7 total and we just found out 4 were kids, that only leaves 3 to be adult tickets. Now, the last letter that says S represents the word, hold on, they solved it by substitution, which we did not, so we're going to ignore all that. Does it make sense? We're going to see now, does this make sense? Well, it makes sense in the fact that it's 7 total tickets, but now let's do the math behind the total. If you have 4 kid tickets and you have 3 adult tickets, how much were the kid tickets? 9. And how much were the adult tickets? 12. What is that total up to? Right, that's the 36 and that's the 36, and when you add them you get 72. Isn't that what they said the total was for their tickets? So it makes sense. We actually did it and it makes sense mathematically. It added up to the right dollar amount that they paid, and it added up to the right amount of tickets that they bought. Okay, now go ahead and turn to page 8. Yeah, yeah, because it'll help you memorize them. Okay, hold on, let me get this stuff out of the way, and then we'll get started. All right, what does R represent? Read the problem. Okay, so let's go ahead and read it. Sally has 20 coins in her piggy bank, all dimes and quarters. The total amount of money is $3.05, so how many of each coin does she have? What does U represent? Underline the question. They want to know what is the problem asking you to figure out? Right, they're asking us, how many of each coin does she have? Okay, well, we have 2 variables because there's 2 unknowns. What are the unknowns? Right, the number of dimes and the number of quarters are what we're trying to figure out, right? So those are our unknowns. Now, do you think it would have mattered had I put X as the number of quarters and Y as the number of dimes? No, it's your choice. It doesn't matter. You'll get the right answer no matter which way you do it. Okay, what did the L represent? Line up a plan, which basically just means set up your 2 equations. Okay, so let's talk about what these equations will look like. We know that we have dimes and we have quarters, right? Dimes, quarters. And what do we know about the dimes and the quarters? They add up to 20 total coins. Now, we're not going to write anything beside X, and we're not going to write anything beside Y, because do we currently know how many dimes there are? No, and we don't know how many quarters there are. We just know together they make 20 total coins. So there's your first equation. Now, what about your second equation? Right, but that 3.05 is a dollar amount, right? Well, don't we know the amount that a dime is worth? Isn't it worth 0.10? And don't we know a quarter is worth 0.25? So when you're working on the equation that equals the dollar amount, you've got to represent the amount of a dime and the amount of a quarter beside their variable. Well, we're about to use the evaluate box to actually do the work. Okay, so now, is it currently set up to like eliminate something right away? What could be eliminated? Not yet. But what would you put and where? Right. Like if this were a negative 0.10 sitting beside that x, those could cross out. So to get it, you just multiply this whole equation by negative 0.10. That'll make this equation become negative 0.10x minus 0.10y equals, what is a negative 0.10 times a 20? Negative 2. Okay, so now that I've multiplied this top equation by negative 0.10, I no longer need it because I rewrote it down here once it was multiplied. Now I'm ready to do elimination. When I get ready to add these, what happens to my x's? They cancel. What happens to my y's? 0.15y, because 0.25 minus 0.10 is 0.15, right? And then what about my constants? What's 3.05 minus 2? 1.05. Now to solve for y, what do I do? Divide by 0.15. And don't forget those decimals or it'll mess up your whole problem. And so now y equals, what is 1.05 divided by 0.15? 7? Okay. So what does that 7 represent? Which is the quarters. Okay, so if we have 7 quarters, that automatically means we have how many dimes? 13, because we had a total of 20 coins. Okay, now let's make sure we forgot to write the word evaluate, which we just did. And now we have to make sure it what? It makes sense. Okay, so if I have 7 quarters, isn't that 7 times 0.25? And if I have 13 dimes, isn't that 13 times 0.10? What does that add up to be? What is 7 quarters worth?
$3. No.
$1.75. And what is 13 dimes worth? And what is that total up to? 305, which is what it said he has in his piggy bank, or she has in her piggy bank. So it makes sense. Okay, I want y'all to try the next question below it, the one that says Jason's wallet. Be working on that one by yourself for a few minutes. Alright, Jason's wallet is full of $5 and $10 bills. He has 25 bills totaling $230. How many of each bill does he have? Okay, so we read it. Now let's underline what they're asking us. What are they asking us? Right. So we need to set up our variables. What do we want X to represent? $5 bills, and Y can be our $10 bills. Okay, now we have underlined what they're asking. We've set up our variables. Now we need to line up a plan. We need to set up our two equations. What is your first equation? Right. You have $5 bills and you have $10 bills. But right now we don't know how many of each. We just know together they make 25 total bills. Not dollars, but bills. What about your second equation? Correct. Since this one was equal to $230, you also need to assign the dollar amount of 5 to the $5 bills and 10 for $10 bills. Did everybody get the equation set up? Okay, so now, are we ready to eliminate one of these right away? No. What needs to be done? Okay, if I multiply this by negative 5, then those would cross out. But I have to multiply everything by negative 5, not just the x. So that becomes negative 5x minus 5y equals negative 125. Okay, does everybody see how I got that equation by multiplying this one by negative 5? Okay, so now this one is useless to it because we changed it by multiplying it by negative 5 and it became this. So now I'm ready to eliminate. What will eliminate? Right, 5x and negative 5x cancels out to 0x. What's 10y plus negative 5y? And what's 230 minus 125? 105. Okay, and then to solve for y, what do you do to both sides? So y, which represents, and it represents what? The 21 what? $10 bills. Okay, so if we have 21 $10 bills, that means we have how many $5 bills? And how do you know that? Because there are 25 total bills. Now, let's make sure that it makes sense. We've evaluated and we have our answers, but now we're going to make sure those answers make sense. If I have 21 $10 bills, how much money is that? 21 $10 bills? $210. And if I have 4 $5 bills, how much money is that? And that totals up to how much money? Which is what they said we have. So we did it right. It makes sense. Okay, we're not doing this one because it doesn't work out, so flip to the next page. We're also not doing this one because it's a repeat of a problem we just did. So now let's go down to this one about Steak and Shake. Okay, at Steak and Shake, 4 burgers and 3 fries cost $26.50. 5 burgers and 5 fries cost $36.25. What is the cost for each item? Okay, we've read it. Underline the question. What are they asking us? Okay, so let's identify our variables. Do you always have to use X and Y? No, and honestly, a lot of times I don't like to. What do you think I would prefer to use in this one? B and F. B for burgers, because aren't we trying to figure out the cost of a burger? And F for fries, because we're trying to figure out the cost of a fry. Yeah, if you want to. You'll just have to remember like if X is burgers, Y is fries, whatever. Okay. Okay, so now we need to line up a plan, which means set up our equations. What does the first statement tell you? 4 burgers plus 3 fries equals up to $26.50. Okay, what does the second statement tell you? Right, 5 burgers and 5 fries equals $36.25. Okay, so stop there for a second. Is there anything right now that we could just cross out right away? No, because your B's have different numbers and your F's have different numbers. Could we just multiply 4 by something to make it become a 5? And could we multiply 3 by something to make it become a 5? So what do we have to do in this case? Multiply both equations. Okay, when you can't multiply by one to fix your problem, you have to multiply by both. So what should we multiply this top one by? Negative 5, because won't that make it a negative 20b? Well, if you're going to make that a negative 20b, what does this one need to be? Positive 4, so that it'll be a positive 20b. Because remember, they have to have opposite signs, so they'll cancel out. So if you make the top one negative, the bottom one has to be positive. Okay, so now, when I multiply this top equation by negative 5, what does it become? Equals, what's 2650 times negative 5? Negative 132.5? Okay, then when I multiply that other equation by 4, what does it become? 20b plus 20f equals 4 times 36.25, right? Is it 25? 145. Yep. Okay, so now that my B's have the exact same number but opposite signs, I'm ready to eliminate because when I add them up, negative 20b plus 20b cancels. What do your F's become when you add them? 5f. And then what do those constants become? I don't think so. Negative 132.5 plus 145 is 12.5. Okay, now to solve for f, what do we do? Divide by the 5. So that means f equals what? And what does that mean? Isn't that the cost of a fry? Okay, so fries cost $2.50. But is there an easy way to find the cost of a burger like there's been easy ways to do all these other ones? Well, right. That's not as easy as the other ones have been, right? The other ones were easy because it was like, okay, 20 total tickets, so we know if there were 13 adults, there's whatever. Those were simple. But for this one, we're going to actually have to plug back in. Now, keep in mind, you can plug into any of the equations you want. You can plug into the originals or you can plug into the new ones. In my opinion, the originals look a little easier to plug into, right? Because they're smaller. Now keep in mind, you're plugging into the original before you multiply it. So like 4b plus 3f equals 2650 was my first original equation. You don't have to plug into that one. You can plug into any of the 4. Why did I not write the f beside the 3 though? Because I know F is 250. So now, don't I have 4B plus, what is 3 times 250? 7.5 equals 2650. And now what do I do? Right? So now 4B equals what? Was 2650 minus 7.5? 19. And now to solve for B, which is the cost of a burger, I divide by 4 on both sides, and so burgers cost, well, what's 19 to 4.75? Okay, now let's make sure it makes sense. We've evaluated now and we have our answers, but let's make sure these answers make sense. If we go back to this first statement that said 4 burgers and 3 fries cost $26.50, let's work that out. 4 burgers at a cost of $4.75 plus 3 fries at a cost of $2.50. Calculate that and see if it really equals $26.50. Yes, so that means we've done it right. It makes sense. Okay, go ahead and be working on the next one by yourself.